Kanisile. Welcome, everybody. We're going to give it 1 more minute. We've got quite a bit to get through this evening. Trigonometry is a big topic, very, very important topic. It's about 1/3 of the marks in paper 2. So, yeah, and if you've been a little bit lost with trigonometry since grade 10 maybe, don't worry, we're going to take it real slow and make sure that you gain a good understanding. Okay, so the question is that you must do the 3 questions that are showing on the board. Question 1, question 2, question 3. For question 1, you have to find tan of angle B and then select your answer A, B, C, D. And then you do the same for question 2. You have to find sine of angle B. And for question 3, you have to find cos of angle A. So this takes you right back to the beginning of grade 10 trigonometry. Right back. Okay, I think everyone is here, so we can start our lesson. For those of you who have started the 3 questions, great. We're going to go through it just now. I'm wondering if maybe we can, I want to ask you, how do you feel about trigonometry? And if you can put an emoji in the chat for me, a smiley face, a neutral face, a thumbs down, a thumbs up. How do you feel about trigonometry in general, grade 11s? Please put in the chat an emoji that shows me how you feel about it. I've got 1. Kabetse, not so much. A little bit of an unhappy face there. Okay, I've got some smiley faces. Melos, no. I see question marks from Asamakle. Sinesipo's giving me a smile. That's great. Rabone's got a little bit of a, I don't know, that's a cat smiling. So I hope that's a good thing. Come, guys. I want to see how you feel about it. I haven't heard from Jolene. I haven't heard from Melo. Untatile, how do you guys feel about trigonometry? Oh, there's Melo. She did give me a Okay, anyone else? Setu, how do you feel? Put in the chat emoji that expresses your feelings about trigonometry. Neutral face. Sade, you've just joined. Maybe you can also put your emoji in the chat, how you feel about it. Okay. Great. So a little bit, I don't see anyone feeling particularly happy about it. So that's fine. We are going to work through this course and hopefully get you up to speed with your trigonometry. Right. So I haven't introduced myself. My name is Marilise Barnard, and I'm just going to be teaching you this week. Next week, Miss Jennifer Godlington is going to take over. So I'm just taking you for 2 lessons, and then she's going to teach you. You've had Depeche for a little while. He taught you on functions. So Miss Godlington and myself will be getting you through trigonometry. Okay. Right, let's tackle these questions that's on the board. And let's see. So this is the very first bit of trigonometry that you learned in grade 10. So I wonder, please, hi Tamelo, I see you waving, hi. Okay, so please put in the chat, what is your answer for question 1? Tan of angle B. Put in the chat, please. Is it A, B, C, or D? Okay. And Nikela, what have we got from the live stream? What are the live stream guys saying? What is the answer for question 1?
So we haven't got any answers yet. We just
Okay.
got mixed feelings about how they feel, equally thumbs up and equal thumbs down.
Okay, so mixed feelings. That's fine. Hopefully we can turn all those thumbs downs into thumbs ups by the end of this course. Okay, so when we do tan is, and we're looking at angle B over here, we always work in relation to an angle when we are doing trigonometry, and that is angle B over here. And when I'm looking at tan, I'm looking at the ratio of the opposite over the adjacent side. So this is opposite, and this is adjacent. Opposite is always across from where the angle is. Adjacent is next to it. That's what adjacent means. And hypotenuse is always the one that is across from the 90-degree angle. So that's also the first thing you learned in grade 10 was which sides are opposite, which ones are hypotenuse, which ones are adjacent. So for tan, I need the opposite over the adjacent side. And for that, that is 3/4. So indeed, A was the right answer. 3/4, because it's the opposite over the adjacent side. Okay, let's have a look at question 2. Sine of angle B. So angle B is over here. I'm coloring it in if you couldn't see it, or just to highlight it a bit. So in this triangle, if I'm looking at angle B, this is the opposite, this is the adjacent, this is the hypotenuse side. For sine, what did you guys say? What is sine of angle B? Put in the chat, please, for question 2. See, have we got any responses yet, Michaela, from the live stream?
Not yet.
Okay. So there is C. Everyone's saying it's C. Let's see if that is right. So for sine, we need to do opposite over hypotenuse, and that is 12/13. So indeed, C is the right answer. Good stuff. And lastly, let's do question 3, cos of angle A. Angle A is over here, coloring it in black. That's angle A. This is my hypotenuse side. If this is angle A, then this is the opposite side, and this is the adjacent side. And cos is always the adjacent over the hypotenuse side. So what is our answer for question 3? You can put it in the chat again, what you think. Yeah, I see A.
It's C.
A. Okay. So adjacent over hypotenuse is going to be 21/29, which makes it A. That one's right. Excellent. Okay. So today's lesson is very much a revision of grade 10 work, because we can't start our grade 11 work if we don't understand or was completely up to speed with what was happening in grade 10. So this is just a quick recap again of basically what we just did. Sine of an angle. So if this is theta, then across from theta, that gives me my opposite side. This is my adjacent side, and the hypotenuse is always across from the 90-degree angle. That is opposite, and this is adjacent. So for sine of theta, I will always do opposite over adjacent. So opposite over hypotenuse, so that is BC over AC. Cos of theta will be AB over AC, because that is adjacent over hypotenuse. And then tan theta is BC over AB, which is opposite over adjacent. Right. Everyone with me so far, please put a thumbs up if you are 100% happy with your 3 basic trig ratios. Thumbs up, thumbs up, thumbs up. Good stuff. See lots of thumbs up. Excellent. Good. Right, let's move on then. Okay. And this is basically where we get to doing trig on the Cartesian plane. Now, I want you to, in your book where you are busy writing and working with me, to draw this diagram. And it's basically the x-axis and the y-axis of the Cartesian plane. You've just done functions, so you're very familiar with the Cartesian plane. So quickly take 30 seconds and draw this diagram. This is x, this is y. Okay, so when we are on the Cartesian plane and we're doing trigonometry, we have to work with angles, right? Because trigonometry has to do with angles and triangles. So on this side over here, and I'm just going to highlight it over here, there's 0. And as I rotate in this direction, which direction is that? That's going anti-clockwise. Okay, so when I'm on the Cartesian plane, I'm always going anti-clockwise. You know, like the hands of a watch go clockwise, we're going the other way. Okay, and that means over here we're going to have 90 degrees. And on this side, 180. And then I rotate some more. And this is 270. And then when I get back there, it's going to be, I'm going to be back at 0, but I would have gone a full 360 degrees. Okay, so this diagram is very, very important to understand for what you do in grade 11. Okay, so you have to understand we're always rotating anti-clockwise. 0 starts on this side, we come right around to the other and complete a 360-degree turn. Okay, that means we've got 4 quadrants. This is going to be my first quadrant, second quadrant, third quadrant, fourth quadrant. So there's always those 4 quadrants. And if you've done trigonometry this year, you'll know about those 4 quadrants already. We are taking this right from the start so that there's no misunderstanding about this. So even if you feel today like you understand what's going on, that's great. This is all still grade 10, beginning of grade 11 stuff. Good chance to revise it because it's likely you haven't done this in a while. Okay, so this arm that I've got here, that I'm going to highlight in this blue color, you can imagine this as an arm that moves, okay? And as it moves, it rotates through the Cartesian plane from 0 right around to 360, okay? So it's like the arms of a clock, it can rotate. And as it rotates, it creates an angle. And that angle, we just call that angle theta. Why the need for these variables? It's just because of the history of trigonometry. They've used these Greek symbols, theta, alpha, beta, because it's the old ancient Greeks that worked a lot with trigonometry. Okay, so imagine this arm that rotates. And as it rotates, we are going to be in different quadrants. But let's just work in this first quadrant. So I've got my arm over here, and what I can do now is I can make a triangle, a 90-degree triangle. And when you make your 90-degree triangle, the 90-degree is always with the x-axis. Okay, I see a lot of people make a triangle like that. No, the 90-degree is always with the x-axis. And because we are now on the Cartesian plane, this distance, this dotted line that I just drew in, that is the distance on the y-axis, so we label it y. And this is a distance on the x-axis, so we label it x. And the hypotenuse side, when we are on the Cartesian plane, is just called r. And when I'm on the Cartesian plane, if I want to say what is sine of theta, sine of theta is still going to be the opposite over the hypotenuse. But because I'm on the Cartesian plane, I have to use the letters x, y, and r. Okay, so on the Cartesian plane, it's the opposite over the hypotenuse, but now we're using y over r. Cos theta, when we are on the Cartesian plane, is now adjacent over hypotenuse, x over r. And the last one, our friend tan, is going to be opposite over adjacent, y over x. Okay. So this is also quite important. That is definitely one of the things you also have to know. When we're on the Cartesian plane, we work with x's and y's and r's. Now, let's just look at this triangle that I drew, and we're going to just fill out this table here to help us know where things are positive and where things are negative. Okay, so if I'm in the first quadrant, and let me change the color here. In the first quadrant, r, by the way, is always positive. Wherever you go on the Cartesian plane, r is always positive. So I'm just going to go right ahead and make it positive. X, when I'm in the first quadrant, I can see that this x here is positive, right? Because it's on the positive x-axis. And my y is also positive. That means if I calculate sine, which is y over r, I'm going to get a positive answer. Positive divided by positive is positive. X over r for cos is also going to be positive. And for tan, y over x, both values are positive. So the whole thing, tan of theta, will be positive. Okay.
No, batlang ba etsa go se.
Okay, so now we're going to carry on. And remember this arm, I said it can rotate. And now we're going to carry on rotating into this second quadrant. And I'm going to put my arm over here. Sorry, it's a bit wobbly. Let me try that again. Okay. And now, because I'm rotating and I'm rotating over into this quadrant, this is where theta is going to be. Theta is going to be that whole angle. And I'm going to make a new triangle. And this is R, this is Y. But now my X is going to be negative, right? Because my X is now on the negative X axis. So X will be negative. So if I go over now to my table, in the second quadrant, X is going to be negative, Y is going to be positive. And if I now work out sine of theta we said is Y over R. So I'm going to take a positive Y divided by a positive R. That will give me a positive number. Whatever the number is, it's positive. But my x's are negative. So x is negative for cos x over r. So it's negative x over r. So that's going to make the whole of cos negative. And tan is y over x. So that will be y over negative x, which will be a positive over a negative, which will make it negative. Okay. Everyone still with me? Please put a thumbs up or a thumbs down in the chat. Just need to check that we are all still together. And if at any point you feel like you don't know, just unmute yourself, talk to me. Okay, Melo says it's all good. Rabone says it's all good. Samahlia, unfortunately, I can't read your, it just comes out as question marks, unless you're meant for it to be question marks, not sure. Okay, thumbs up, thanks, Samahlia. The steady says it's a thumbs up, awesome. Okay, so are we ready to move on to the third quadrant? Let's rotate away. Okay, so we're traveling through. And now our arm is coming through the second quadrant into the third quadrant. And I'm going to make it this color. Okay, so here comes, now my theta is this here, right? Okay, so let's make our triangle. And remember, it never goes like that with the Y. No, it's always with the X axis that you have to make your triangle. And let's put in where our R's and our Y's and our X's are when we are in this quadrant. So this is going to be negative Y, because look, we are now looking towards the negative Y axis. R stays positive, X is negative. So let's fill in our table. We've just said X is going to be negative, Y is negative. So what do you think sine is going to be if we do negative Y over positive R? That's going to give me a negative. And X is negative for cos, so X x over r for cos is a negative over a positive. That's negative. But tan is negative y over negative x, which will make that positive. Okay, so let's continue. That's our third quadrant. And our arm keeps moving and it's rotating and it's making an angle and it rotates right through into the fourth quadrant and it's there. All the way. That's theta. And let's make our triangle again with the x-axis. There's my 90 degrees. This is still going to be minus y because we are on the negative y-axis. R stays positive and x is already there from when we worked in the first quadrant, and that is positive. So what color is this quadrant? It's green. Okay, so our x's are positive, y's are negative. So y over r will be negative over positive. That's negative. And cos will be positive. X over r will be positive. And tan will be negative y over positive x, which will make it negative. Okay, so if you have redrawn this table and you've got your table going, then make sure that it looks like mine, because now we are going to put into the different quadrants where the different trig ratios are positive and where they are negative. So in the first quadrant, we see that sine, cos, and tan are all positive. So I'm going to make an A here. All trig ratios are positive in the first quadrant. We saw it here. We discovered it over here. We worked it out. That was the first quadrant. In the second quadrant, only sine over here is positive. Cos and tan are negative. So I'm going to make an S here for sine. That means sine is positive, tan and cos are negative. So the S only indicates which trig ratio is positive and which one is positive. In the third quadrant, we only have tan that's positive. So I'm going to make a big T here. Tan is positive in the third quadrant. That means sine, look at our table, sine is negative, cos is negative. And then in the fourth quadrant, cos is positive. So I'm going to make a C. Cos is positive in the third quadrant, which means tan and sine are negative. And we saw why that was, right? We worked out the whole thing and we saw why that was. So what have I got here? I've got this cost. That's where the whole cost diagram comes from, this abbreviation here, cost. Where the three trig ratios are positive and negative on the Cartesian plane. Now, you might know cost. Sometimes I talk all stations to Cape Town, all for the first quadrant, stations, second quadrant to Cape Town. It's a way to remember it. It's just a way to remember it. Has anyone learned any other ways to remember it? All stations to Cape Town or cost? Can you give me a thumbs up if you've learned cost before, the cost diagram? Or if you've learned another way, like I know all stations to Cape Town. Is there anyone who learned a different one? All singers take cough sweets, all students take place, all stations to Cape Town, Tamelo, you with me? All singers take cough sweets. I like that one, Malang. Anyone else got something different? Okay, it seems like we're all on cast or all stations to Cape Town. But if you've got a different way to remember it, that's fine. As long as that is going to be your job before Thursday, you have to be very familiar with this cast diagram or the 4-quadrant diagram or all stations to Cape Town. You have to know off by heart where sine is positive, where tan is positive, cos is positive. But you also have to know where they are negative, in which quadrant. Okay. This must become like something, if I wake you up in the middle of the night and I ask you, sine is positive in which quadrant? Then you tell me, my release, the first and the second, and then you go back to sleep. Okay, that's how well you must know it. Because this is not something that you can spend time on in a test or exam wondering about. Okay, this is something that must come to you like the times tables. Okay, you have to know this very, very well. So your job for Thursday already is that you must make sure that you know exactly where your trig functions are positive and negative on the 4-quadrant diagram. Okay, that before we can do proper grade 11 trigonometry, that is something you must know. So if you've struggled with trigonometry up to this point, it is likely because this is one of the things that you didn't understand or that you didn't work hard enough on. Okay, so now's your chance to fix that. Right. Okay, so that's going to be your bread and butter for trigonometry. Who knows these ones? Special angles. Who knows those? Sinisipo, Sipisigle, Sesetu. Do you recognize these? Tumelo says yes. Tokozane says yes. Yes, ma'am. Romelo. Okay, good stuff, guys. Valerie, do you know your special angles? Okay, I don't want to spend too much time here today on special angles. It is really something that you can work out. We used to, in the old days, have to draw these triangles, but we do now have calculators. Okay, so it is something that you can do with your calculator. So I want you for Thursday, that's the other thing you must do to prepare for Thursday, is to do sine, cos, and tan of these 3 angles, 30, 45, 60. You can draw your own table like this and do the ratios for sine, cos, and tan for 30, 45, and 60. It's very simple. You go on your calculator and you say sine of 30 and you get a half. Now, the thing is that you can never, ever, when you answer a question about special angles, do not ever use a decimal fraction. It must always be in a surd form or in fraction form. So sine of 30 is a half, for instance. Now, if I do cos 30, you'll see on your calculator it's √3/2. But you can also use your triangle here. So here's 30 degrees, and cos is adjacent over hypotenuse. So it's √3/2. That's what you write down when you do special angles. You never ever give a decimal because that is what's called a breakdown. Have you guys heard of that? It's a big word that you're going to learn now that you're grade 11 and you're about to write matric next year. A breakdown means misunderstanding, no marks, we stop marking, you've just done the question completely wrong. Okay. Sinisipo, do you have your hand up? Or is that an old hand? Sinisipo, I see that you have your hand up. Is that an old hand or do you have a question? Okay, maybe just take it down if you, okay, just take it down, please. Thank you. Okay, right. Let's do some questions back to our quadrants. So this is something that, just to get back to the special angles, I want you to do this by yourself for Thursday. Okay, let's see. First question, in which quadrant will theta lie in the following cases? So, cos theta greater than 0. What does this mean? It means that cos is positive. In which quadrant will cos be positive? Put it in the chat, please. Well done. Okay, so that's our first answer. Well done for those guys who have answered. Everyone else, join us, please. Put your answers in the chat. Do not just sit there quietly. Participate, please. Okay, cos theta greater than 0 in the first and fourth quadrants. Okay, where's sine smaller than 0 and tan greater than 0? Let's see, I'm going to ask someone to do this for us. Rabone, can you tell us where's sine theta smaller than 0 and tan greater than 0? So where is sine negative and tan positive? Rabone, this is your question. Okay, can someone help out, Rabone? Let's see, Adam. Okay. There's Rabone. Okay, thank you. 3 and 4. Okay, but it means that sine is negative and tan is positive. So those two things happen at the same time. So Day says it's in the third quadrant. I agree with that. Sine is negative in the third quadrant, and at the same time, tan is positive. So it's the third quadrant. Okay, where will this angle be? 275, which quadrant? Fourth, I agree with you, Adam, fourth quadrant. Okay, now let's try question D. Sine of theta is positive or greater than 0, and cos is greater than 0. So that must happen at the same time. Where are they both positive at the same time? Put your answer in the chat or unmute yourself and talk to me.
It's the first quadrant.
First quadrant, I agree with that. Because in the fourth quadrant, cos is positive, but sine is negative. And in the second quadrant, sine is positive, but cos is negative. Okay, and then in which quadrant are they both negative? Sine smaller than 0, cos smaller than 0. Where will that be?
The third quadrant. The third.
Third quadrant. Is that you, Sinisipo?
Yes.
Third quadrant. Thank you. Great stuff. Okay. let's do some questions with special angles. Okay. I'm going to give you 2 minutes to try this one on your own. Sine 30, tan 45, sine 90 over cos 60. What do we see here? These are all special angles. So immediately you have to think this over here, but you can use your calculator. You can just not write anything as a decimal fraction. It must be as a surd or as a common fraction. Okay, give it a go. Let's see how this goes. 2 minutes, and then we'll see what the answer is. Okay, Matlochonolo has already come up with an answer. That's 1. Remember, you must show all your steps. Again, it's if you go straight to answer, you'll get no marks. Okay, you must show each and every step. Okay, 30 more seconds, and then we're going to look at the answer. Okay, so first thing we do is we replace. Sine 30 must be a half. Tan 45 is 1. Sine 90 is 1. And cos 60 is a half. And then all you get is a half divided by a half, which is 1. Can I get an indication in the chat, please? Thumbs up if you got it right. Adam, Asemachle, Malang. Okay, with all your steps. Must show steps. Okay, good stuff. Looks like we're all good with this. Okay. Right, let's move on. And this is going to be, this is like the last thing you learned in grade 10. That's, you know, that's quite important. And that is how to find an angle when you only have trig ratios, and how to find a side if you have an angle and a side. So I'm going to do this first one with you, just to refresh your memory. You need your calculator here, definitely. So this first, let's call it A and B. Okay, here's theta. So when you're trying to solve for theta, you look at the sides that you have. The sides that you have, hypotenuse, adjacent, opposite is missing, so we can't use that. So we can say cos of theta is adjacent over hypotenuse, 6 divided by 10. How do I get theta if I have cos theta is 6 over 10? Who knows? It involves your calculator, by the way. Who can tell me?
Don't you use Pythagoras or something? Or shift cross, yeah. Yeah, it's right.
Yeah. We are trying to solve for an angle. Remember, we are not finding a side. Pythagoras won't help much to solve for an angle. We need trigonometry and we use our angle. So on your calculator now, go shift cos 6/10. If you have another type of calculator that's not a Casio like this one, I think you have to use second function maybe. Second function cos. Okay, so shift cos 6/10. And you should get theta is shift cos 6/10. 53. And we're going to round to 2 decimal places, 0.13. Okay, who got that? If you got that, then move on and do question B. Everyone else, please show if you didn't get it. Sesetu, you got it. Malang got it. Adam got it. Good stuff. Anyone else? You can start on question B. First, tell me, who can I ask? Who hasn't said anything? Trish. Trish, which trig ratio are we going to use in question B to find theta? Trish, you can just unmute yourself and give us the answer if you know. Anyone else?
I think I'm gonna use tan D2.
Tan. Trish is also tan. Great. Why do we use tan? Because if I look at my theta here, this is the opposite. This is the adjacent. This is the hypotenuse. I don't have a value for the hypotenuse. I've got the opposite side and the adjacent side, and we know that tan is the ratio for opposite and adjacent. So tan theta is 12/12, which just is 1. So on your calculator, you go shift tan 1, and it's 45. Okay, so that's finding an angle. That's also very important from grade 10 that you still remember that. Let's go to question 4. Now we're going to find sides. And we have to find side BC. We don't know what BC is. For both of these, we need to find BC. What are we going to do now? Now we make a ratio with the side that you have and the side that you want. 60 degrees is the angle. The side that we have is the opposite side. The side that we want is the adjacent side. So we're going to use tan. Tan of 60 is 7/BC. Is this coming back to you, grade 11s? This is grade 10 stuff. Still going to use this in grade 11. You can't forget it. Okay, so tan 60. What do I do now? Well, now I can remember this tan 60/1. Tan 60 is a number. We've seen that when we say tan of an angle or anything, it gives us a number. So then BC tan 60 is equal to 77, not 77. But I still need to get BC by itself, so now you divide by tan 60. And that you now put into your calculator. 7 divided by tan 60. And what do we get? I get 4,04. That's BC. Round to 2 decimal places. Okay. As the last question for today, do question B. Just like I did this one now. The side that you have and the side that you want, use that to make a trig ratio. Which ratio are we going to use? Who can we ask? Asamachle, which trig ratio are we going to use to solve for BC in question B? You can put it in the chat or you can unmute yourself. Asamachle says sine. Why do we use sine? Because the side that we have is the hypotenuse. The side that I want is the opposite. Oh. So. Sine 52 is BC over 14. This one needs less maneuvering than question A. We can just cross multiply. We're going to get 14 sine 52 is equal to BC. And then BC, I get 11,03. Okay. Who also got that? Let's see in the chat. If you got that, you can put a thumbs up. Okay, Asamachle, good stuff. Okay, so that's it for today's lesson. We're not going to get to these last few questions. That's fine. We can do them another time. I just want to see with this overview of grade 10 trigonometry, can I just see, give me an emoji, how you feel about what you learned today? Please put it in the chat. Adam, is your mind blown? Jolene is smiling. Okay, good stuff. We see some smiles here. Wonderful. Everyone else, where are you? Valerie smiling, good stuff. Samuel's clapping, good stuff. Sade, and Tatile, you smiling as well. Okay, looks like we've got some smiles. Remember, for Thursday, go make sure that you know back to front your cast diagram. Sinesip doing cartwheels. Wonderful. Over to you, Nicola.
Okay, hi guys, good to see you back. Well done to everyone. And yeah, just to go through some of the stuff, just to just my screen share quickly. Okay, so yeah, you'll see that this was our trig. And just to give you an overview, we have done our lesson 1, which was our grade 10 revision. And our next lesson is on the 26th, and that's Pythagoras type questions. So yeah, so you know what's coming. For your homework, you're going to go to your app. You're going to look for the topics. Once you click on topics, you're going to look for trigonometry, click into that, and then scroll down, and then you'll see trig on the Cartesian plane. And then the first one that's there, which is trig on the Cartesian plane. That's what you need to do. And yeah, like Marilee said, revise, make sure you understand for our next lesson. But yeah, well done to everyone. And it's great to see all of you back.
Okay. Thanks, Nicola. Okay, I think that's it for today, guys. Thanks so much, and I'll see you again on Thursday. Bye.
Bye, guys.
Bye-bye.